morning. Welcome to second lecture of the analytics course, applied analytics course, where we are learning analytics from a practitioner's viewpoint. And we are going to cover all the three aspects of analytics: descriptive, predictive and prescriptive. So today we are going to talk a little bit more on the decision making support, how analytics is going to work on the decision making and support the decision making process. So, as we mentioned earlier in the class or in the first lecture, introductory lecture, in early 90s and 2000s, the data mining and computational statistics, these two, which we can call it as the, they can be called as the precursors of analytics. Okay. So, both data mining and computational statistics were exclusive. This was exclusively used to big companies, because why? The answer is because of the large financial investments. Because of the large financial investments that are required, this was only exclusively meant for the big companies. And the smaller companies or maybe for other companies who are not that big, they had major roadblocks or major issues. Okay. And what were some of those major issues? The most important one would be the data collection. In those time, or even presently also, to decide how frequently you need to collect the data. Okay, that's one question. What all data to collect. That is another issue. Then we have another one is how to store. Okay, sometimes this in the form of database or file, okay, etc. So there are quite a lot of issues that comes with the data collection aspect of it. Then the second aspect of it would be trying to make sense out of the stored data. Okay. The question is how to make sense. Okay. And what is actually the sense, that aspect. Then the third aspect is decide what all techniques to use. Techniques to be used. Okay. So, these were major roadblocks, because these questions are usually, they all differ from organization to organization. They all differ from organization to organization, and within an organization, problem to problem. Okay. So, the requirements in this case is quite difficult. And so then what happens is, analytics slowly matured from what we call as this business intelligence. So, the organizations initially who were doing data mining and computational statistics, okay, that require, the first step is collection and storage of data, of, let's call it as relevant data, which is what we call as the business intelligence. Okay. And once you have that, once you have the data being stored, it actually slowly matures into analytics. And so what happens is, BI involves collection of data and information for future usage. Okay. That is one part. Then once the data plus info available, okay, opportunity for predictions, estimates, etc. So, you can see predictions and estimates slowly starts to come into picture. Okay. So, then this way BI, so if you think about it as time progressing, the time is progressing in this regard, matures to analytics. Okay. So, when you have all the data stored and then you have the data available with you, then you start using that for doing analytics. Hence, okay, plus the advent of open source tools drastically reduced cost of analytics. For example, SAS versus R. Okay. SAS is a very expensive software which is used for earlier statistical computational statistics and data mining, but now there is an open source version of it which is called as the R. Okay. So, this all resulted in from niche organizations to small and mid size organizations. So, the analytics started being from the big companies to the small companies. So, if you think about it in a graphical format as the time has progressed, so here we had only those big corporations, just kind of drawing big corporations like this. Okay. They were only doing what you call as data mining and stats, computational stats. Okay. This was only being done by them, and the finance money was like lot of money was involved in this. As time progressed, what happens is one was new tools, new free tools. Okay. Then you had other thing was called cheap storage. Okay. And then you had cheap hardware, cheap power, computational power, okay, etc. They were all coming in. Then you had like all the medium size, okay, organizations and the small size organizations, okay, reasonably doing analytics. So, then the BI translated to analytics. That is how it actually evolved. Okay. So, now we will talk about the next ones. What are the major obstacles to doing analytics in an organization? There are four major obstacles. There could be many, but we can classify it into four major. So, this is a broad classification. You could find any of these in any organization, and if these are identified, then it need to be addressed. So, the first one is called as the management obstacles. This is a category. Okay. So, what are the major management obstacles? The most important thing that you would see is the dedicated resource commitment. The resource could be in the form of this could be manpower. Okay. Then you have facilities, then R&D, etc. Okay. So, these are all dedicated resource commitments which will require continuous support. So, because in organizations mostly analytics is a staff function. Okay. A dedicated team is usually available for doing analytics. Hence, you require dedicated resource commitments, which means you have to invest money in this regard, okay, financial investments. Then second part is translation of R&D into operational realm. So, what happens here is findings of analytics is used in decision making. Though this sounds simple, but many a times this is actually an issue in industry, purely because of the fact that the decision maker, the large scale decision maker or the big decision maker, usually have a tendency not to follow the recommendations of the analytics team. They are like, oh, I know better. I have been in this job for so many years. Why should I listen to a bunch of people who are not made any big decisions? So, because a lot of people consider analytics as still as an R&D input, and there are many incidents where these such inputs have been discarded, and finally, if you take in the long time, you will see that the analytics will be telling something and the decisions will be going in the opposite direction. So, that should be avoided. So, for that the management need to put its foot down and basically get the things done and say that, well, we are going to do data driven decisions. So, and for that we are spending this much of money. So, better we should show outcomes for it. So, that is the one part. Second one in this regard, or second obstacle in this regard, is the data obstacles. So, this is common in many ways in many organizations, and data requirement in a specific format, that is usually the biggest problem. Specific format depending on the model used. Okay. So, what we are trying to say here is that depending on which model you are going to use, the data that you are going to do would require in a specific format. So, usually what happens is, so it becomes difficult to change the model to something new, having different data requirements. So, you would probably see that many of the organizations that actually do analytics, the changing of a model to a new advanced one with a very different data requirement, they tend to avoid that because their data storage, the business intelligence require large amount of revamping, which requires a lot of money in that regard. Okay. The other time is lack of capability to capture the data. Okay. It could be due to the process, like a high temperature process or something like that, or it could be due to lack of infra, okay, or non availability of sensors. Let us say you are taking some data, etc. Okay. So sometimes you cannot capture the data just like that. Like, so for example, if you look at if you don't have the sensor to do a particular temperature, or so, like for example, you want to do some process in which the temperatures are extremely high, and you don't have a sensor that could withstand that temperature, then you can't capture that data. So that's a point. So sometimes the process will make it extremely difficult to capture the data. Sometimes the other factors would make it extremely difficult to capture the data, and sometimes it becomes such an issue that you can't capture the data at that frequency that is needed. So it becomes an issue. So then finally, the last part is populating data fields sufficiently and consistently. Okay. So the data fields need to be populated sufficiently and consistently. So you should have consistent data and you should have sufficient data. Then the third point that we are going to talk about it is the modeling obstacles. So you have data obstacles. We kind of alluded to what would be a modeling obstacle would be. The modeling obstacle typically is called as the major issue is overfitting of the model. The model. This literally means that the model is very too complex. Based on the data, your model is too complex, which results in memorization of data, in historic data memorization. Okay. So when it results in historic data memorization, what happens is that this creates two issues, the major two issues. The first issue is that performance on new data is poor. Okay. The other part is that interpretation of model becomes unreliable. So when you provide new data, because it starts memorizing the historic data, when you provide new data, it has a poor performance, and the model becomes unreliable when it is interpreting. When you interpret the model, it becomes an unreliable thing. So these two are the outcomes of the modeling obstacles. So now, so how do you solve this modeling obstacle? I am going to write on the top: solution to modeling obstacle is to start with simple model. Okay. I cannot emphasize this much more. So we are going to use a new principle called KISS principle, okay, which means keep it simple and stupid. So start simple. This is the big mantra that you require when you're doing modeling, especially in data analytics. And then the last one, the last obstacle that we are going to talk about is the deployment obstacles. Okay. And the deployment obstacles, the major thing is when you implement both the data and the models, the time requirement to combine data and obtain model parameters. So when we are talking about this, we are combining data and we are obtaining model parameters on the fly. On the fly means real time. Okay. When you're doing it in the real time process, then when you're doing this, it may not fit the standards set by operating system, DBMS, browser, etc. So many a times we will see, if you book your website train tickets in IRCTC, you will actually see that sometimes it takes a long time and sometimes it takes operation timeout, because it is trying to combine data and applying the model onto the top of it, but then it actually beats the session timing of the browser, and then you get a session timeout. So sometimes the other party operations, like things like the third party softwares or third party applications, app requirements, this is very hard to meet certain times. Okay. So that is some of the reasons why when you have a very complicated stuff that you are working on, then you will see specific or custom built system made available for this process. Okay. So we now talk about the next process. Why do we need decision making? Everybody talks about decision making. The most important question is, why do we need to make decisions? Okay. Well, the first and foremost thing is, rational decision making helps the organization. Okay. It helps the organization in many ways. Okay. So the first and foremost thing is that decisions, when you are taking better decisions, when somebody takes a better decisions, it results in focused actions. Okay. Better decisions translates to focused actions. Your actions are focused, and when your actions are focused, you get close to desired results. Okay. So the reason is that better decisions also translates to clearer goals. Okay. So if you are taking better decision, rational decisions or data driven decisions, your goals, why are you making the decision, that is very clear. And once you know why are you making the decision, then it will give right to focused actions. Once the focused actions are there, then you get very close to the desired results. And when you desired results, mostly in an industry, it is profit and efficiency. So you increase your profit, you increase your efficiency. Then there is something what we call as a scientific decision making approach. Okay. Which is where there is one other alternative to this is not the emotional or we can call it as whimsical decision making. Okay. It's like not my hunch. I am just I'm going to make the decision because I feel so, not that way. It's a scientific decision making approach. It is based on data and there is a specific process involved in it. We will discuss this in the next slide. But what it does is it reduces the time. Reduces the time means time to take a decision. This is the classic example of this is bureaucracy. The time taken for them to make a decision is extremely large, and hence it translates to what you call as risk. So as time progresses, risk increases. Okay. This need to be thought through, and then obviously cost also. So if you decide that we are going to build a building today, it might cost you 1 crore rupees. But if you say that okay, no, we'll wait for 2 more years and then we'll build the building, it would probably then cost double or triple that time money. Okay. So that is an example of by delaying the decisions or waiting for more time, usually does not reduce the risk and the cost. It actually do the counterproductivities, usually increases it. And the other part is that rational decisions, when you talk about rational decision making, it is continuous in nature. It is continuous in nature means you take decisions and you follow up. Okay. There is follow up, which means it results in a closed loop system. So if you think about it, you have the inputs of the decisions and you have the system you make your decisions and you have your outputs, and typically if you are making a rational decisions, there is a feedback always, and the system will slowly will tend to what you call as a course correction. It will correct itself so that the expected behavior of the system becomes what is desired. So, you will reach the desired behavior in as time progresses. So, time is kind of continuing here. Okay. Then the another part is it also empowers the people to make decisions. Okay. Or what is the major important part of it? Because if the decision maker is not empowered, the person who is supposed to make the decision is not very sure that if I take this decision, and this is the decision that I have taken in my good faith, which means based on all the data, all my emotions were thrown out of it, I have taken the decision properly, and I hope that the organization, the upper management will stand by me. So, if I know that the upper management is also making rational decisions, they only look at the facts and they do not look at other things at all. If that is the case, then everybody will be happy to make the rational decisions. They will not think whether if I make this decision, then will that person be happy or this person be happy. That kind of if that kind of questions are eliminated, whether the happiness or individual feelings or emotions are taken away from the decisions, and you will just focus it by using data driven decisions, which is what analytics do, then rational decisions, people are empowered to make decisions. And the final point is it also increases the organizational intelligence. So, organizational intelligence is increased by, how is it increased? It is increased by being informed, controlled and adaptive. Okay. So, when we say organizational intelligence, what do you mean by organizational intelligence? Okay. As people learn, organization is consisting of people, as people learn to take decisions, what happens? Or when you empower people to take decisions, they tend to act more intelligently. And when people act more intelligently, what does it do? It translate to organization acting intelligently. Okay. So, the organization acting intelligently literally means that the people in the organizations are acting intelligently, and their intelligence actually come from being empowered to take data driven decisions, for which they happily use analytics. Okay. So, you can kind of see how the analytics and can help in this critical process called decision making. Okay. Now, let us talk about the decision maker, okay, the person who makes the decision. What are the major factors, okay, that influences the decision maker? And the decision maker is a person who exhibit a range of beliefs, okay, and the belief in this case is not the religious belief or anything, but what we talk about here is how strongly one accept or differs on issues. So, we talk of here is the degree of acceptance or difference on an issue. Okay. And what are the major factors influencing this belief or this individual acceptance or differences on issues? The number one is the evidence. Okay. Well, this is not the evidence of the law enforcement, but this evidence is called as what we call as what is the prior knowledge. Okay. What is the prior knowledge in this regard? Knowledge about the issue, which means it can, in a better way to say this about is domain knowledge. So, what do you know about what is already going on? So, sometimes more the domain knowledge, it can translate to stronger beliefs. Okay. So, that is one part, the evidence. The second part is the compatibility. Okay. So, here when we are talking about compatibility, that we are talking about the agreement with the world view of the individual. Okay. How compatible it is, like, so like for example of this is, let me put as an example here, the trickle down effect of money. Okay. So, what happens is, pay top people more, okay, uh, people at lower position will also get more eventually. This is a belief that a lot of people do harbor, and I am not an expert to say this, but people do believe this. The best way for giving money to the lower employees or something is to pay the upper management high. So, when the salaries are high, then slowly it will start trickling down to the uh, lower employees, because they will also would like them to bring them up higher, because the differences will be huge and those kind of things. So, if the person believes that, then the actions will always be, the decisions will always be dependent upon that world view, that view that there is a trickle down effect of money. So, these kind of things can happen. Then the third part is, the third factor that is about is reliability. How reliable is the source of information or data. Okay. So, a classic example of this is, government provided data versus info in social media. So, somebody goes to their Facebook and posts something, and some government official comes and says, we have absolutely no idea, we don't agree to this. Then obviously the people would start to believe the government source, because people would say that, okay, one source is more reliable than the other, kind of a thing. So, the how reliable the source of the information or data is also one critical factor that typically influences the decision maker, because if we know that the source is reliable, then tend to believe the data more, or your belief is better. And the last part is the accepting and doubting. Here when we talk about it is, what are the consequences of accepting or doubting the decision. Okay. So, for example, the main example here is voicing difference in opinion. So, if you know that if you don't agree with the top management, you are going to voice a different opinion, and if it is going to hurt you, or if it is going to create issue to you, then obviously you may not be comfortable in doing it. You would probably decide that, okay, fine, I am going to stay away from this, or I am not going to voice my opinion or difference. On the other hand, if the organization promotes such kind of voicing of difference of opinion, then obviously you will tend to voice it strongly, and all the difference of opinions are heard. Another example. So, a classic example of a company like this is Honda, who actually promotes opinion difference. So, Yoshida Honda always used to say that if the other person is an yes man to you, one of you is different, one of you is defunct or obsolete, kind of a thing. So, anyway, so all these factors influence the decision maker or the belief of the decision maker, which then translates to the decision. So, when you provide data, when you have reliable data which is compatible with the world view of this, and there is prior knowledge, evidences or hypothesis available with that, and the consequences of accepting or doubting are understandable and clearly articulated, then decision maker tends to make better decisions or rational decisions. Now let's talk about what is the scientific decision making process or SDM. Okay. We already mentioned there is a scientific decision making process involved, and there are many versions of this available. Okay. Different views on this. Okay. People provide different views about it. But in almost all the views, you can kind of find these 5 major elements. Okay. In most of the variants of these views, there are 5 major elements reside. And what are these 5 major elements? The first one is called as the goal. Okay. And the goal literally means objective of doing the analysis. Why is the analysis being done? Okay. So, this is the first part of it, goal. Second part is the model. Okay. It is typically an abstraction. In many cases, it is all abstractions, all possible abstractions. Abstraction literally means you are only taking what is needed and unwanted things are thrown out, all abstractions of what is being analyzed. So, an example of a model is that let us say that there is a bank teller. So, this is a bank teller and there is a queue, people come here, okay, and wait at the teller, and then they get the money and they go away. Okay. So, people go away out of the system. Let us think about a simple system which is called as a single server queuing. Okay. So, the factors that you are looking predominantly here, one will be the arrival rate, the rate at which the people are arriving, and the other one is called as the service rate or service time. Okay. You do not really care what color of the dress this the teller is wearing, or what is the dress, the race, caste, creed of the customers. So, these are your customers. Okay. So, you will only take these relevant information and the rest of the information is distracted. So, this or discarded. So, this abstracts the system. Okay. So, that is what we talk about here as a abstraction. So, all models are an abstraction of the system that you are going to study. Third part is the data. So, what is data? That are observations that represent the scenario or process in which the model is to be tested. Okay. So, the data gives you the scenario or the process where the model needs to be tested. The model is the abstraction of what it is, and then you are going to test it on a given scenario which is represented by the data. And then what you have is evaluation. So, what you do here is compare the model to data and decide the suitability of the model. You are saying whether this model is working okay for the data. The abstraction that you are using is working for the data. And then revision basically means change the model if evaluation results are not okay. So, you are saying that okay, fine, we evaluated the model with the data and then we found that it is not fitting, it is not compatible. So, hence we change the model. So, these aspects, the goal, these 5 steps, the goal, the model, the data, the evaluation and the revision is quite common in the scientific decision making process. Okay. So, what we do here now is We provide a modified scientific decision making process, modified SDM for analytics, for the analytics that we are interested in this particular course. So, we basically start with, let us start with the diagram means always you can start drawing boxes. Okay. So, we will say understanding of business. Let us call that as the first starting point of ours. Okay. And then from there we go to something called as understanding of data. Okay. So, from here we move here. Okay. So, once you think about understanding the data, sometimes what happens is once you start playing with the data, you get something called as a better understanding of the business, and this loop can continue couple times. Then once you reach a reasonably good understanding of the data, you move into what you call as a prepare necessary data. Prepare necessary data. So, once you understand the data, you move into what you call as a preparation of the necessary data. Then once you have that part, then what we do is we basically move into the next step, which is called as develop models. Okay. You go in this fashion. Sometimes when you are developing the data, you find out that okay fine, or model, then you say that okay fine, the data is not in the right format, then you end up iterating there. Okay. Finally, at one point of time when you are comfortable with what the model is, then you do the next step, which is called as evaluate the model. Or evaluate the models. Okay. So, from the development of the model, you evaluate the model, and once you have the model with you, you can do this. It actually would better your business understanding, and you could repeat this process, which is another loop. Or once you are comfortable with this, then what you call as you do something called as deploy the decisions or decision deployment. When your model fits whatever it is, then you can say okay fine, I am going to use this model to deploy the stuff. So, where is data in this whole mess? The data is at the center. Here is what the data is. This whole thing is happening around the data. So, the understanding of the business is what we can call about as the problem definition. Okay. Or here we can talk about it is an understanding of the data, where what we are trying to do is you are examining the data. All right. So, these things translates to what we call as the goal of the aspect of this system. Then we do talk about it is we prepare the necessary data, where literally means that we are fixing the problems, fixing problems in data. Okay. And in also one part it is that create derived information. A classic example of this would be somebody's date of birth might be given to you, and so age from D or B is an example. Okay. This is a derived aspect. Okay, fine. Now, once you prepare the necessary data, then what you do is you develop models. Okay. And so, here what you are doing is build analytic models. This is the modeling aspects of it. Okay. So, the ask earlier is that the goal model. So, this is the goal, this is the data, okay, which is explicitly here. Then you have the models. Once you have the models, then you have evaluation, which is assess and report model performance. Okay. This is the evaluation aspect of it, and the decision deployment means decide which model to use and how are you going to use the output of the model to make decisions. So, this is the SDM that is typically available or typically practiced in the industry. You start with understanding of the business, then you understand the data. So, we call this as the loop 1 and we also call this as the loop 2. Okay. And we need to talk about these feedback loops L1 and L2 and we will discuss this immediately. So, these feedback loops, there are 2 loops. Okay. So, what do they demonstrate? The feedbacks loop, okay, and they demonstrate common practices of process modification. Okay. So, modification in industry. Okay. So, what we do here is the loop 1 L1, what we talk about it is when decision objectives are defined and then data are examined. When you are done your digital, when you defined your decision objectives and then you are examining the data, okay, then various lacuna or deficiencies in data, this can be quality, quantity, okay, both, okay, relevance, all these aspects will be part of this, will be evident. What it would do is redefine objectives or revamp BI. So, either you would redefine your objectives or you would change the process in which you are collecting the data. So, this first feedback loop typically is a refinement, typically a process refinement that happens there itself most of the time. Okay. The second loop L2 that we see in the previous slide, that is based on what happens is that the model that is built has poor accuracy. Okay. So, then when you have that, what do? You revisit the data to create derived variables, okay, scales, etc., to improve accuracy. So, sometimes you find that instead of the individual data points, so you can say that individual data points data may be translated to what you call as classes. Okay. Date of birth translated to age, etc., like this. So, sometimes you might come across some derived variables which might give you a better performance to the model. So, that the internal modification of the data is done then and there. So, this is to obtain better performances of the model, better model performance. Okay. So, these two feedback loops in reality do happen during the scientific decision making process on analytics within the industry. And these two feedback loops to a large extent, they improve system, which means the feedback loops do realize system improvement. Okay, where efficiency is definitely improved, which will translate to better financial returns. Okay, so we I hope that at least you understand from the way how analytics is supporting the decision making and why decision making is important and what is the scientific decision making process, the aspects behind the scientific decision making process. That aspects of this course, I hope it is clear to you guys. And in the next lecture, we will cover the new concepts, data and other aspects, what are the type of data and other things. So, till the meantime, continue reading and learn more and more as you can. Wish you all the best. Thank you.